Here's the question then. Question 10, here's the picture. That's the bump which goes with the picture. It's all in the picture. The volume is 96000. The surface area is S. A, B, C, D. There's the parts. So I've got it all summarized here. And let's have a go at it. I've just done a little bit of work here, but just to scratch it around, I'll just get rid of this and do it again. Just having a look at it. So first of all then, we need to work out the volume. Given the volume is this, show this. So first of all, this surface area we need to work out, don't we? Because this surface area times depth will give the volume. This area here is 6 by 4, which is 24x squared, plus half base times height. 2 times 3 is 6x squared. So the total surface area of the front is 30x squared. So the volume, V, is equal to 30x squared times the depth, y. And that's 9600. So for part A then, 9600 is equal to, what was it, 30 x squared y, 30 x squared y. So it tells us that 3 goes into 960, 320. So y is equal to 320 over x squared, which is what we wanted to show. Now the surface area. Well, the surface area will be the cross-sectional area, which we've done before, 30x squared, plus the area around these sides here. The depth of these rectangles is y, that's the length of them, and there's the lengths of these distances here. So you've basically got 10, 15, 24x times y. 24xy it will be, won't it? And we know that y is 320 over x squared. So it's 30x squared plus 24x times y, 320 over x squared. So 30x squared, 320 times 24 times 320, 7680, which is what we wanted. One of the x's cancels, so there's just one x underneath. Write this in user-friendly form for differentiation. So when is S a min? ds dx we'll need, won't we, using calculus, is 60x using the power rule, and again minus 7680 x to the minus 2, one less. That equal 0. There's a 60 common, hopefully. X. Oh, and an x. No, it's not. Yeah, take an x out as well. Well, we've got 60x minus 7680 over x squared. So I'm going to take a 60x outside a bracket. Hopefully the 7680 goes into 60. If not, we'll do something less. 128. So it'll be 1 minus 128. I took an x out from above, so I've got to put another x in underneath. What was that? 128. Yeah, okay. Okay. So I've shown the surface area as that. Okay, so let's let that equal 0. That implies either x is 0, which is not interesting, or x cubed is equal to 128. Here's the question, diagram-wise. All the information is contained in the bump here. It says the surface area is S and the volume V is 9600. And there's 4 parts to the question, A, B, C, D. Got it all summarized here. So the first thing is show that, given the volume, show that y equals this. So the volume, well, we'll need cross-sectional area times depth, won't we, for the volume. So I'm going to drop a perpendicular from C onto that line here, AD. This is 4x. This is 6, this is 9, so this will be 3x. So this area, which we'll need, the cross-sectional area, will be 4 times 6 is 24x squared, plus half base times height. 2x times 3x is 6x squared. So that's 30x squared. So that's that area there. So volume V is equal to cross-sectional area 30x squared times the depth, which is y. And that volume is 9600. So what have we got here? Well, let's cancel by 0. Then 3 goes into 960, 320 times. So then y will equal 320 over the x squared, which is what we wanted to show. Here. Now we'll show the surface area. Well, we've got 2 of these, front and back. So there'll be 2 lots of the surface area, which is 2 of these. So B, S is equal to 60, 2 lots of 30. Plus, and then all the strip in between, let's just go up, is basically rectangles. This one, this one, this one, and this one. Length times breadth. This is y all the way along, all 4. You've got 6x, 5x, 9x, and 4x, all times y for those 4 areas. So it's 15, 24xy. 24x's times the y's, which is 60x squared, plus 24 times 320. 24 times 320, 7680. X times 3 over x squared over the x squareds. So the surface area then is 60x squareds plus 7680, and x cancels, there's an x underneath, and I'm going to bring it on top. Because in the next part, that's the surface area then, we want ds dx to find the minimum. Power rule, 120x minus 7680 x to the minus 2. 20x minus 7680 over x squared equals 0. Let it equal 0 when. So does 120, see if we can take out 120 common factor. Divide by 120, see if it does. It does 64. So 120x, I'm going to take that out. 1 minus, what was it? 64 over x. Now we took out an x, so I'm going to put an x here and an x underneath in the bracket. So that tells us that either x equals 0, which is no solution as far as this is concerned, or x cubed is equal to 64, isn't it? Cube root x equals 4, because we only want the positive solution. So x is 4 then. Now part D, let's see if it's a min or max by getting the second derivative. d2s dx squared is equal to 120, because x goes to 1, plus 7680 times 2, $15,360. Okay, so that would be x to the minus 3. So that would be over x cubed, put it like that. which is greater than 0 when x equals 4, clearly. So S is a min. We needed to work out the minimum value. S is equal to when S is 4. So 60x squared plus 7680 over 4. 60 times 16, or times 4 squared, plus 7680 divided by 4. 2880 centimeters squared is the surface area that's a minimum.